a warm welcome on behalf of Statistics Department of conducting one-day webinar on analysis of data used in art. The aim of the webinar is the statistical techniques in research studies using art. First of all, I would like to express my deep sense of gratitude to our beloved Vice Chancellor, Professor D. Yamuna Madam, for her encouragement and motivation for conducting this webinar. I am very happy to express my sincere thanks to our registrar, Professor T. M. Mamata Madam, for her support to organize this webinar. It's a pleasure to welcome Professor SP and DB. I also welcome Professor G. Sandhya Rani Ma'am, convener of the Department of Statistics. I feel very happy to invite today's resource person, Dr. S. Nafis Umar sir is Assistant Professor, Department of Statistics and Computer Applications, SV Agricultural College, Tirupati, and Arya Satyanarayana sir, Senior Data Analyst, Airwaka Technologies, Vijayawada. A warm welcome to the teaching faculty of our university and other universities, research scholars and students for this national webinar. Once again, I extend a warm welcome to one and all. I wish you a very informative and meaningful request, Sukanya ma'am, to intervene. Over to Sukanya ma'am.
Okay. Hello, is it audible? Sir, Nagaraj sir, is it audible, sir? Nagaraj sir, వినిపిస్తుందండి? Participants, is it audible?
మేడం వినిపిస్తుంది కానీ చాలా డిస్టర్బెన్స్ గా ఉంది, చెక్ చేసుకోండి.
కాల్ చేయండి. పద్మ కాల్ చేయండి.
Now it is okay. Now it is okay.
Audible sir, Nagaraj sir?
Now it is okay.
చెప్పండి, ఇంకా రాలేదు. వినిపించట్లేదమ్మా, రాని ఫోన్ చేయమంటున్నాను. Dear participants, there is some technical problem. We are attentive to that one. Please wait. Padma phone చేసి ఎవరు అదే నేను చెప్పిన గబగబ చూడండి అమ్మా నీకు చెప్పమనిలా ఆడియో కూడా రావట్లేదు గట్టిగా మాట్లాడండి అమ్మా ఓకే
Thank you, Smita ma'am. Myself, Sukanya, academic consultant, Department of Visvavidyalayam. In this context, I would like to present a brief introduction of the Visvavidyalayam is the first women's university in the state. It is popularly known as SPMB. SPMB was founded in the 1983. It is the brainchild of the student It established this university with the intention to and its acquisition of knowledge. Initially, the university was started with 10 departments with 30 teaching faculty and 300 students. Now, the university is teaming with 59 courses, 5,500 students, 105 teaching faculty, and 1 test fund. The Department of Statistics was established in 2014, offering MSc Statistics as a self-finance program with 32 students. The department also exhibited skills in statistical analysis in the research problems related to home science, biotechnology, social work, economics, education, etc. Now the department is teaming with 45 students and 4 teaching faculty members. The department also offering consultancy services to different departments, research scholars and students within the university and other universities also. There is a very good response to the department, and every year the number of students applying to join the department is increasing. Now I invite Professor P. Sandhyarani Madam, Convener, Department of Statistics, to introduce the theme of today's webinar. Over to Sandhyarani.
Thank you, Sukanya. Respected Dean of School of Sciences, Professor R. Nagaraju sir, esteemed resource persons, Sri Satyanarayan Garu and Dr. Sheikh Nafiz Umar Garu, participants from various universities, departments and colleges, research scholars and students. A very happy and pleasant good morning to you all. It is a privilege to me to introduce today's national webinar theme, Analysis of Data Using R. In recent years, R has gained popularity because this software is free and open source. This language is designed and mainly used in statistics, data science, and in statistical communities. Among academia and in more research-oriented fields, R is a valuable tool as these fields of study usually require high scientific and unique modeling. R is actually used for statistical computing and design. It has brought about revolutionary improvements in big data and data analytics. It is the most widely used language in the world of data science. Some of the big shots in the industries like Google, LinkedIn, and Facebook rely on R for many of their operations. R is an open source performing language developed by Ross Ihaka and Robert Gentleman in August 1993. They decided the name for this language with their name's first letter R. Hence, the more for this is R programming language, and the stable version of this language was released in December 2018. It has been developed for statistical computing and graphics supported by R Foundation. This language is widely used among statisticians and data miners for statistical and software and data analysis polls, data mining surveys. As of February 2019, or ranks 15th in TIOB, the importance of being earnest index. Or language includes conditional loops, user-defined recursive functions, and input-output facilities. It is a very flexible language and does not necessitate that everything should be done in OR itself. It allows the use of other tools like C and C++ if required. OR provides an extensive, coherent, and integrated collection of tools for data analysis. It has an effective tool handling and storage facility. It includes a package system that allows the users to add their individual functionality in a manner that is indistinguishable from the core of OR. OR language has an impressive growth in recent years. There are many programs in OR such as OR Ecosystem Migraph, extension packages, and CRAN, OR Studio, and many more. OR language is the preferred choice amongst data analysis and data scientists because of its rich ecosystem catering to the essential ingredients of the big data project preparation, analysis, and correlation tasks. OR easily connects into a variety of traditional databases and perform basic data processing operations remotely on the server through SQL queries without explicitly importing large amounts of data to the OR environment. Spark also connects very well with OR through its Spark OR package. At present, OR is the variety of algorithms and statistical models it contains. In view of the growing importance of OR language and its rapid expansion in big data analytics, today's national webinar is organized to know more about the use of OR. I once again welcome our Dean, the resource persons, and all the participants to the webinar. We want to learn more about from the resource persons on this language, and I once again thank you all for joining this webinar, and I convey my thanks to the coordinators for giving me this opportunity. Over to Sukanya.
Ma'am, to introduce our Dean sir.
Thank you, Sukanya ma'am. Myself, T. Sukirti, working as academic consultant, Department of Statistics. I deem it very great opportunity to introduce our Dean School of Sciences, Professor R. Nagaraju sir. He had 20 years of research and 33 years of teaching experience, guided 10 PhDs and 8 PhDs are on roll. 73 papers are published in seminars and conferences. Sir awarded as Best Pharmacy Teacher by Association of Pharmaceutical Teachers of India 2018. Sir received State Best Teacher Award in Pharmacy subject by Government of AP, National Best Teacher Award in 2017 by CVS Krishnamurti Charities Tirupati. And also Sir received Best Teaching Pharmacy Award in 2017 by Indian Pharmaceutical Association Tirupati. National Level Pharmacist Award 2017 in the category of Scientific and Innovative Research Award by Seemandhra Drug Dealers Association and Andhra Pradesh State Pharmacy Colleges Management Association. Sir also received Pharmaceutical Scientist of the Year 2017 by Andhra Pradesh Council for Science and Technology, Government of Andhra Pradesh. Sir was Distinguished Alumna Award of Manipal College of Pharmaceutical Sciences, Manipal 2005. He also received Achiever of the Year 2002 award by AVOPA Bangalore. And Sir received grants from DST, UGC, AICTE and awarded with 2 patents in dental implants. Now I invite our Dean, Professor Nagaraju sir, to address the participants on this event. Over to Nagaraju sir.
Thank you, Sukirti, for your good introduction. Thank you. It gives me a great pleasure to address this particular seminar. It is very, very, very important. And to, as our head has already said, this department is very young in the School of Sciences. It is only from 2014. So, and we have a great, good team of youngsters and all lead, on the top led by the experienced Professor G. Sandhyarani garu. And the admissions to this course is full. Many times we receive recommendations to take more students. So that is a reputation of the department, and the department is doing very good in all aspects. So with this, I move on to the topic what is being selected, and it is very apt. All of you know very well that there is no meaningful research until unless we infer them. So data collection is one hand, and data inference is on another hand. Analysis of the data is on another hand. To come out with a good inference, the data should be analyzed properly using the proper whatsoever the system data analytical tool it is going to be. In pharmaceutical research, we do use at the end of the various research findings, various statistical tools. And one such tool is very important for the youngsters. And also I see in the participant are almost 100, very great number to listen. That speaks about the quality of the seminar and the quality of the speakers what the department has selected. So I hope we are going to listen more to the from the speakers of the day. That is Dr. Sheikh Nafiz Umar. I am seeing him. Thank you, sir, for accepting our invitation to be a part of this seminar. And also Satyanarayana Garu from the Vijayawada, an industrialist, where he is accepted to become, as the speaker of the day. And it is very aptly designed. It's only two speakers. That is only very nice. Many times I tell my department colleagues, online webinars not more than two speakers, because the people will get fatigue in sitting in front of the computers for 6 hours, 4 hours or so. So it is very, very well done. So I hope the participants have really get the benefit out of whatsoever the time they are spending with the distinguished resource persons. I'm sure they are going to give you a live examples and how this particular data and also new vistas. It is always very important rather than from the textbooks. Listen to the people who are actually using. Listen to the people already who are experienced. So therefore, we will get the students and researchers will get in first-hand information about this particular tool, whatsoever it is going to be. So I wish a great success of this particular seminar organized by Department of Pharmaceutics, and also I wish all the participants will take home a good good material from you, so that this is going to be a good, a memorable event to start in the week. So I also thank Professor Sandhyarani Garu for giving me this opportunity to speak with you. And probably I should be excused because 11 o'clock I have one meeting where some information has to be sent to the higher education immediately. So probably immediately I'll leave the meeting with the permission of all of you. Once again, all the best. And the speakers, please interact with the people. Please share your email IDs, so that if any people wanted to contact you, especially give the first preference to our students, right? Mahila University students, for your interaction. Please help them out in doing the better one. Thank you very much and all the best.
Okay, sir. Thank you, sir.
Thank you so much, sir, for your valuable speech and taking time out of your busy schedule to address the program. Once again, thank you, sir.
And taking time out of
Now
your busy
it's time
schedule
to
to address the
introduce
program.
resource person
Once again, thank you, sir.
R.A. Satyanarayana, working as senior data analyst,
Now
Airwalker
it's time
Technologies
to
Private Limited,
introduce
Vijayawada. He did his master's in statistics from Acharya Nagarjuna University, Guntur. He worked as a project associate for several projects under the guidance of Professor G.S.R. Anjaneyulu in
in statistics from Acharya Nagarjuna University to several academic projects. Acharya Nagarjuna University for two. His specializations are Python, SQL,
tools like R Studio, Data Studio, Power BI, and SQL Server or ggplot or Flex Dashboard, SAS, and SPSS. He had 5 years experience in business intelligence and data analytics, data mining, data pre-processing, statistical modeling, machine learning, fetching data from REST API to R, and reading and writing to Google Drive, Google Spreadsheet, and R and Python. He acknowledged as one of the authors in the paper some aspects of econometric techniques in banking sector, published in International Journal of Emerging Technologies in Computational and Applied Science. He is one of the board members of Statistics Department in Sri Padmavati Mahila Visvavidyalayam, Tirupati, Andhra Pradesh. Now I invite Satyanarayana sir to take over the session. Over to Satyanarayana sir.
Thank you, Sunita, giving this opportunity. And good morning to everyone. Now I'm sharing my screen and presenting the today's agenda. Are you able to see my screen? Hello? Hello? Hello?
Yes, yes, go ahead.
Okay.
Satyanarayana, sir.
Yeah,
Sir,
okay.
it is okay, sir.
Yeah,
The
okay.
screen is visible, sir.
Yeah, okay, thank you.
You
So,
please go ahead, sir.
okay.
We are able to hear you.
Yeah, okay, thank you.
Highlight.
Yeah. So today's agenda is the installing the R software and installing R Studio and introduction to decision tree and AD3 algorithm and entropy and information gain and advantages and disadvantages of decision tree. These are the today agenda topics. So how to installing the R? Okay. The step one is the go to this shared link. Which opens this window on Chrome web page and select the and click on the download R for Windows. Okay, then again open this window on Chrome, then download the R 3.6.1 version for Windows. After downloading the version, and double click on the your downloading file, it shows this this window. Then you select the language English, then click on the OK. Then it shows the license agreement window. Just read it once, this license agreement, and just click on the next. It will show the components of your installation. So if you are using 32-bit OS, then click on the 32-bit OS. Or if you are using 64-bit OS, then click on the 64-bit OS. After that, click on the next. Okay. Then click on the next. If you are placing the path on C drive or D drive, choose the browse on the your drive and click the next button. Okay. Then click on the next button to create desktop shortcuts or icons on the desktop. Okay. Then it will take 1 to 2 minutes for installation time. After that, it will show the window finish. Okay, then finish the, after installation is complete, then finish the click on button. Okay, this is the installing R. So now move to the how to install the R Studio. So this is the installing for R Studio. You click on the download button R Studio. It will appear the screen on Windows. Then click on the download for the R desktop version free. Then it will open the welcome to R Studio setup window. Once your R Studio is completely downloaded, then double click on that execute.exe file. It will open this window and click next and browse your path location where to install the R Studio, whether it's C drive or D drive. Once you are set up your path location, then click on the next. And it appears some window. It's R Studio or R accessibilities or administration tools. So you select the R Studio and click on the install. Okay. And it will take 3 to 5 minutes time for a complete installation process. After that, it will completing the installation. It will appearing the window. Then finish the window. Okay. Are you able to get my points? If you have any doubt, please ask me for installation steps. Okay.
Participants, please respond if you have any queries.
Okay. I move to next slide.
Please proceed, sir.
Yeah, okay. So once your installation is completed, if you open the R Studio, it will you will see the 4 windows on the screen. So first window is the source. Here we enter the code and you enter the script. You write the your own programming on here. And second window is the console window. Here it is also your execute queries on this window, and we will quick outputs on in this window. And this window is the third window is the environment and industry window. Here you can save the objects and you can see your history of the codes. And here you can see here you can connect your databases also here. So if you are working on SQL database, you can directly connect the here environment window. I will show you next practically how to connect them. And fourth window is the files window and plots window. Here you can see your working path files and how if you are plotting any plots, you can see the fourth window. And if you have any doubts on your working libraries, you can search for help. You can use for help button, and you can see your functions also. Okay. So yeah, move to next slide. So here, what is the difference between and R Studio? Yeah, R is a software application. It is you can use directly you can write programs on the R and execute the R. But in R Studio is a IDE version, integrated development version, right? Uh, so if you run the code on R Studio, you must install the R first. Then you can use the R Studio only. So R Studio is
Sir,
the
here
higher
is a
quality.
question from the participant.
Can you repeat once? I am not able to get your point. Okay, move to next slide. So this is the introduction of decision tree. So why decision tree is the algorithm? So what is the use of decision tree algorithm and why to use decision tree algorithm for real-time data? So decision tree is the most useful machine learning algorithm. It can be solve a variety of problems. So there are few reasons why should you use decision tree. It is considered to be most understandable machine learning algorithm and it can be easily interpreted. Okay. So it can be used for classification and regression problems. Like for example, if you are working a loan company, uh, if you disburse a loan for particular customer, so that customer is able to is able to loan or not. So if you are working, if your target variable is the person is eligible or not, so yes or no. So this classification problems also will work on decision tree and will work on regression problems also. If you are predicting the sales of the particular product, so you can use decision tree also. It will give the good results. Okay, and it handles the non-linear data also. It will handle the decision tree. Some of the machine learning algorithms may not be handle the non-linear data, but in decision tree it can handle the linear data also. Okay, and decision tree is a very quick process, and it is uses only one feature per node to split the data. So if you okay, I will go for next slide. I will explain deeply. Okay, so decision tree is a very versatile machine learning algorithm. It can be perform both classification and regression tasks. Okay. So here training events and categories is the where training data set. If you build the registry algorithm, here new events is the test data set. If you pass the test variables and registry model, you will get the outputs of the model. That is the category. Okay. Okay. To get better understanding of registry, look at an example. Okay. Uh, if you host a use party and you want to know how many guests were non-vegetarian or no vegetarians. To solve this problem, let's create a sample decision tree. Okay. So this is the did you guest eat this chicken? If yes, non-vegetarian. If you know, did you guest eat mutton? Okay. Can you please observe this picture? You will get the how to work the decision tree algorithm. Okay. Did you guest eat the mutton? If it is yes, the guest is a non-vegetarian. If it is no, did you guest eat for seafood? If it is yes, is a non-vegetarian, and if it is no, is a vegetarian. So I will go for next slide. Here the did you guest teaching is this is the root node of the data. Okay, and these are the branches. It connects the node node to internal nodes and node to the end of the leaf node. And this is the internal nodes. This is the leaf node. So the root node is the starting point of the tree. At this point, the first split is performed. Okay. And internal node, each internal node represents a decision point of that eventually leads to the prediction of the outcome. Means this is the leaf node. Okay. Leaf nodes represent the final class outcome, and they're also called the terminating nodes. Okay. So branches are connection between the nodes. They are represented the this arrow symbol. Okay. Did you get the object of the decision tree, students? Okay, I go for next slide. So how does the decision tree work algorithm work? Okay, uh, select the future variable. That's the best classify the data set into the desired class and assign the feature to the node. So you need to select the best classifier variable. Means here the best classifier variable is the guest. Did the guest eat the chicken or not? This is the best classifier variable in this example. Okay, and step 2, transfer the down from the root node while explicitly making the relevant decision at each internal node such that each internal node the best classifies the data. So we are giving the scores between the each predictor variables. So first, we're getting the higher scoring variable is the best classifier variable. Then the next is the second classifier variable. So until it repeats the class input variable. Means this is the class input variable here. Okay. So repeat the process until reach the output variable. Step 1 step. This process only for classification purpose only. If you are using regression method, then will steps is changes the steps. Okay. In decision trees, you can use so many algorithms in decision tree. Like ID3 algorithm is one of the method you can use the decision tree, and the CART method. So couple of methods is there. So in this method, best method is the ID3 algorithm for using decision to build the decision tree. So ID3 algorithm means the iterative decomponizer 3 algorithm is the one of the most effective algorithm to build the decision tree. It measures the works only 2 concepts: entropy and information gain. Okay. These are the steps to build the decision tree for using ID3 algorithm. First, select the best attribute of the variable. So best attribute means if you are I will give you one example. Okay, if you are predicting the sales of a particular product, suppose you are predicting the sales of a Cadbury chocolate. Okay, this is the target variable, and Here the independent variables is the price is the independent variable. You are predicting the price of the Cadbury chocolate. Here price is the your target variable, and uh, types of Cadbury chocolates, right? So that is the one of the category, and add is the one other another attribute. So these two are their independent variables, and price is their target variable. So if you are applying, if you are building the decision tree on this data here, which is the more correlated to the your target variable, that is the your best attribute variable. So okay, for each value of attribute, build a descendant of the nodes, and assigning the class labels of the to the leaf node. If data is correctly classified, then stop. Hello. Okay.
Yes, sir. Please proceed.
Yeah. Okay. Yeah. So how to select the best attribute, right? So for selecting the best attribute, for using the for attribute for using the entropy and information gain. Using these two methods, you can select your best attribute of the decision tree. So entropy is the measures the impurity or uncertainty present in the data. It is used to decide how to decision tree can split the data. So okay, it is the equation to find the best entropy of the attribute. Okay. Next, information gain. So information gain is the most significant measure to build the decision tree. It indicates how much information of a particular variable gives us the gives us about our final outcome variable, means our dependent variable. Okay. And information gain is the most important because it is used to choose the best variables to split the data of each node of decision tree. Okay. The variable with highest information guide is used to split the data at the root node. So uh, if you get the highest score on the your independent variables, that the variable is the your root node using the information gain method. Okay. So now go to advantages and disadvantages of the decision tree. Yeah, as earlier said, the decision tree is a very fast way to identify the significant variables to relation between two or more variables. Okay. Hmm. In decision tree output is very easy to understand. Even analytical background people also it can easily understand, and its graphical presentation is very intuitive, and users can easily relate their hypothesis. Okay. For example, if you are working on a large data set, you have hundreds of columns. So how to your significant variable those hundred columns? So you can easily interpret your which variable is significant to your target variable. You can easily identify using decision tree. And less data cleaning is required. If it is any outliers on your data on missing values, it can inbuilt handle the decision tree. And data type is not constant, so it is works for classification problem and numerical means regression problems also. and it can handle the non-linear parametric data also. Okay. Disadvantages of decision tree. It's most it is most disadvantage is that it is overfitting the data, but it gets solved by setting up the constants model parameters and tuning the method. So it is not fit for continuous variables. While working with your continuous numerical variable, Destiny lost the information when it gets the categorized variables in different categories. Okay. So it can handles the classification problems very giving good results. If you are building the regression problem, well you are independent variable having a classification column, having different classes in that column, it may lose some information in that column. So this is the one of the disadvantages of the decision tree. Yeah. Any doubts about this session from theoretical part? If you have doubts, please ask me. I will clear the doubt. Otherwise, I'll go for practical example. Hello. Hello. Madam, Madam, I'm not getting your voice clearly. Some
Participants in the chat box, sir, which is
hello.
To install.
Madam, I'm getting your point. Can you repeat once? Some disturbances is coming here.
Sir, you can continue, sir.
Yeah, okay. I'll go for practical example on this model. Are you able to see my R screen?
Yes, sir. It is visible.
Okay. Just a minute, I will explain.
Okay, sir.
Okay. Okay.
At the end of the section, we will share the PPT, ma'am.
Okay. For I will introduce. This is the data. I'll give a small example of data. So this is the data set. Here color, size, and points and readability. Okay. This is the record. This data is recording to the mushrooms. Okay. So if color is red and size is small and points getting a S, that is the toxic. Maybe it is the poisonous of this mushroom. Okay. So for understanding, I'm giving the small data size. If you get understanding, I will go for next big data on this. Okay. First, you need to find the best attribute on this data set, right? Here, the readability is our target variable. So I'm predicting the sixth row of this data set. Well, I'm using I'm giving these three input variables. Okay. So it will give the so applying the entropy from readability and the color. So here color is brown, readability is the 2 and toxic is 0. And if it color is green, it is the 1 readability and there is no toxic. If color is red, if the readability and the toxic also is 1 1. So this is 1 and this is 1. Right. So I want to know which variable is the best gives the best information of this data set. Okay. So here I'm getting the score is 0.32 for checking the entropy of color and readability columns. So here, okay, I'm finding the next column. So here I'm finding the size and readability of the entropy. So it gives the 0.1 score of the readability information of size. Same here, I'm checking the points, how much information gives the about readability. Again, it will give the 0.32 score. So here I'm getting the most highest score is the points and color. So you are considering the only one. So I'm considering the here color is our root node because it gives the highest information gain about EWT column means target column. So based on the color column, I build the some tree. So this is my tree based on color column. So a color column gives the more information about the our target variable. So I consider the color is our root node. So this is our root node color. So we call the color size and points are called as the features and attributes. We call. Now I'm predicting the next. So I'm predicting the sixth row. So if my color is red and my size is large, if points is yes, so what is the class of the ability here? So okay, this is the edible. So this is not a poison. If I give some another parameters, maybe this is small. This is no. Means it is a toxic. So it gets the information from the this algorithm. So it gets the information from this tree algorithm and it will give the um, predicted output. Okay. This is here I'm using only for my own functions here I'm using. So because your data size is very small, only five observations here my data set, so that I can use my own functions. If I have large data set, I will use inbuilt functions in R. So these are the libraries required for building the decision tree. So I'm reading the file from CSV or local server, my local server. So this is our data set. Okay. Here the number of observations is 8,124 and number of columns is 23 columns. Here you can see here. Okay. So how to find our most attribute variable means root node. Okay. So again, you can use entropy method for all variables. and which gives the best score of the column, then you can select that is the root node. But it is the long process, right? Because we are having the 23 columns, so that I can use this libraries for in this libraries it can handle the it can select the best node, best attribute on the data set. So this is it can show us the structure of the data set, means data types of the data set. Here class is our target variable, right? These are the variables we have. Suppose so here the two classes in our target variable. One is E and one is P. So E means eatability and P means poison. So eatability records is 4208 and poison records is 3916. Okay. I'm checking the data is any missing values or not. For checking the missing values using the sapply function. This function gives the missing values information of data set. So there is only one column having a missing records. That is the GIL attachment column. So out of remaining columns having there is no missing records. So class has a zero missing records and cap shape has a zero missing records. So only one column, GIL attachment column is having a missing record. So I repeat the where missing values. Okay. Now I'm checking the uh, now go for which variable is the gives the most information game our class variable. So here class is our target variable and order is our root node. Just I am assuming this is order is a root node, but we can see the which is the most information variable on the plot. Okay. You can see plot, right? Here the order is the giving the highest score on the comparing the remaining variables, and next is the SP color above ring, and next is the SP score color below ring. So here is the root node is I preferred root node is the order because it giving the highest information gain of our class variable, right? Then before I go for building the modeling, I need to split the data as a train and test, because I build the model on train data set and predict the data on test data set. This is the function to split the data and train and test. So here I'm taking the 80% is our train data and remaining 20% is our test data. So you can see the six 6,500 records is our trained data set. And 1624 is our test data set. Whole records is the total records is my actual data is 8,124, right? So is with the data 6,500 is the trained data set and 1624 is the test data set. So now I go for build the decision tree. So this is the function to build the decision tree, right? Here class is our target variable. I'm giving it, this is the data set, trained data set name. A PAMS list loss penalty matrix means it will it will give the uh, most significant variables in order way. Means this it will give the order like this type. So it will give the ascending the variables and most information gain of the data. So that I used here penalty matrix method. So I ran this code. So see the output. Now you can. So here here our training set has a 6,500 records, and here the root node is our order is the root node. Okay, I will show you an tree diagram so that you can understand that you can understand easily. Same output I'm showing you the tree plot. Yes. So this is the our output and this is the plot of the output, right? So here order is the our root node. Okay. I will show some data. So this is order column, right? So in order column having a multiple classes. So how many classes in order column? So I will show the how many columns in order. So there are how many orders? So in order column having 9 classes, right? Out of 9 classes, here only A, L, and are the best classes on the our target variable. So we'll check the data. Why it is best classes on this target variable. So I'll show the data. So class is our target variable. Or is our root node. Why you are taking the order for root node? Because it will give the most information is the only A, L, and classes only. So here see the 400 observations on A and 400 observations on L and most observations on N, 3,408 observations. So that it will give us the most information gain about our class variable, so that I consider the order as the root node. Okay. So after that, which variable gives the most information about our target variable. So this variable is the most information gain. So which variable? Score PR. Okay, there it is. So that's next gives next it gives the next information about our class variable after order class order variable. It gives the pollution column, right? This column it gives the uh, gives the best information about our target variable. So in this pollution column having again two classes, habitat and habitat. This is the habitat column. It gives the 50% of the it gives the info of 50% of edibility and 87% of uh, poisons, right? I'll for next. Now check for the predictions of our test data set, right? This is the function to predict the classes on test data set. So and run this code. So this is the output I'm getting on my test data set. These all are the predicted variables. So how much means or I will check the what gives the what accuracy of the model. Okay. If you check the accuracy of the model, you can use the confusion matrix. So this is the predictor variable. Here the header is the predictor variable and this EP is the actual values. This is called as another name as a true false was name true false rate means it gives the information about how much accuracy to build the model. So here I'm applying 95% of constant interval. I'm getting the 0.99 percent of the model. So means it almost it gives the 100% of the uh, accuracy of the model. So and get the cost predicted values is 1. Actually, this is the overfitting the data. And if you build any model, it will give only 72 to 95% of accuracy. But here I am getting the 0.99%. It means 100% accuracy. So there is an overfitting error in this data. So so I need for fixing the overfitting error, I need to uh, train our data set using our another model. Means maybe I used to ID algorithm here, but I need maybe I used to carrot means chi-square mm, classifier algorithm, chi-square classifier algorithm. It gives maybe better results on the ID3 algorithm. So here I'm getting the 100% accuracy on test data set and at 95 constant interval. For the model accuracy is the 0.99 percentage means 99 percentage. So this is the code to build the decision tree. That's it. That's it then for today. If you have any questions, ask me. I will clear on that. Hello. Hello.
Hello, sir.
Hello. I'm not getting your point. Can you repeat one?
One question from Nagesh sir. He posted how, sir.
Can you repeat one?
Sir, question from the participants, sir.
Okay.
How to know overfitting errors, sir?
Yeah. Okay.
Fitting errors. Sir,
Okay.
how?
Okay. Okay. I will explain how to find your data. Your model is overfitting or underfitting, right? So I'm giving you two methods. You can check if your model is good fit or underfit or overfit. So I'll give two methods. You can check your model. First one is if you build the model on your trained data set, right? Same way you can build the model on test data set. Okay. If they will give you some significance values. Means I will show the example. Suppose so this is the summary of our output. Based on this output, we'll find your model is the correctly fitted or overfit or underfit. So it will give some scoring of your predictor variables. Where it is. Okay, I will give you one best example for finding the model is good fit or not. If you build a linear regression model, right? So if you build the model on a trained data set, you will get an R-square value, right? So if you are getting the R-square value is the some 0.75 like that. So same again, you build the model on our test data set. So again, you get the R-square value on our test data set. It will get it will close to the trained data set value. Means our trained data set value is the 0.75 and our test data set value is the 0.7 or 0.69 like that. So it's the difference between the trained and test data set values is very less. Then the model is very good, and then the model is correctly fitted. If the difference is very large, means positive value, means your trained data set is the again 0.59 and test data set is the 0.8 or like that. So here difference is very large. So if the difference is the positive number, means 0.8 minus 0.5, here is getting the 0.3 is the positive difference. Like, so this difference is the overfitting. This difference we call it as the overfitting. For before building the model, you can check the data is correctly fitted or not. We can apply the model on our trained data and test data set and check the R squares on both the trained and test data sets. And if the difference is the high difference on positive number, it will the overfitting. Otherwise, we are getting the negative number on high difference. That is the underfitting the model. That is the model is underfit. So if the model is underfit, what you do? So if the model is underfit, then you need to check the your independent variables. Means if you are getting any um, uh, means if you are getting correlations between in independent variables, then identify the that variables and use the and remove that variables. So for identification of that variables, you can use the variance inflation method. It method helps to identify the uh, correlations between the independent variables. Okay, only independent variables to identify the correlation. So variance inflation method is the best method to identify the uh, correlations between independent variables. So it will give you some score. This method will give you some score. It will give the it makes the 0 to 10 is it gives the 0 to 10 range. If we get the above 5, that is the variable is the maybe it gives some that variable is the one of the cause for overfitting of the data. So we find that those variables and remove that variables in our model. Again, we build it on the model. So based on this logic, you will get the you will overcome the our model is overfit or underfit. Okay. I hope you clear your doubt. I think. Hello.
Okay, sir. Now proceed, sir.
Can you repeat once? I'm not able to get your point due to some echo error is there. Uh, from my end, this session is over. I'm stop sharing my screen.
Once see chat box, sir. Sir, is it audible, sir? Sir, there are some questions in the chat box, sir. Yeah.
Okay, so I will share. Okay. Here the question is how to fit time series regression model by using R. Okay. So you can use ARIMA model. Then if your data having a if your data having a day-based data or weekly data, you can go for ARIMA model. Okay. ARIMA model gives the best result for daily data, means daily data set and the monthly data sets. If you're having a monthly data, you can use Holt Winters method. It will give you the best results for the monthly data set. Okay. And best R-square value is based on our data set. So based on your business requirement, you can see your R-square value. Right? Normally, R-square value is the 0.7 to 0.665 to 0.9. This the range is the best R-square values. Yes, Sunita, I hope completed my end. I will share you codes also. Hello. Hello. Hello.
Any questions from the participants? Sir, is it visible? Sir, it is audible, sir?
Yeah, no, I'm audible.
Any questions from the participants? Any questions from the participants? Okay, sir.
Okay, students.
Thank
If you have any
very
question,
much,
please mail me. I will give the answers. Okay. Yeah.
Okay, sir.
Yeah. Okay. Okay. Okay.
Thank you
Sunita.
very much, sir.
Yeah. Yeah.
I
Thank you.
hope
Giving
you
this.
all enjoyed this. Yes, sir. For a such very good the present topic. Actually, I am very happy. I am very sure that all the students inspired with your topic because they have introduction to the art in their curriculum. They really enjoyed your presentation. I'm sure about it. Thank you very much, sir. Now, I request Vani ma'am to introduce Dr. S. Nafis Umar sir to the participants. Over to Vani ma'am.
Thank you, Sunita ma'am. Myself, A. Vani, working as academic consultant in Department of Statistics. I deem it a great opportunity to introduce Dr. Sheikh Nafis Umar sir, Assistant Professor, Department of Statistics and Computer Applications, SV Agricultural College, Tirupati. His academic qualifications are MSc, PhD, MBA Marketing. He had 7 years experience in teaching and 10 years in IT and Computer Science Corporation in Genpact EMRI App Labs. He specialized in advanced econometric model and some statistical software packages like SAS, SPSS Clemente, Minitab, EBUS, Sista, or Programming and Predict. He guided 15 PG and PhD students and published 4 books and 75 national and international papers. Now I invite Dr. Sheikh Nafis Umar sir to take over the session. I invite Dr. S. Nafis Umar sir to take over the session, sir.
Okay, so I'm audible.
Yes, sir. Yes, sir.
Yes, sir.
Okay, so for first of all, I'm thank to so far conducted a national webinar on analytics for data using R. So first of all, I would like to thank to Register Professor D. Monta Madam, Dean of School of Sciences Professor R. Nagaraju sir, and today's webinar there is convener Professor G. Sandharani Madam, Head of the Department of Statistics, and coordinators T. Sunita, M. Sukirti, Sukanya, and Vani Madam. Okay, so I thank to earlier the resource person R.A. Satyanarayana Garu, Senior Data Analyst, Eurobaka Technology, Vijayawada. Very good afternoon. Okay, so before going to slides, I'm introducing myself. My name is Dr. Sheikh Nafiz Umar. I'm working as a assistant professor at the Department of Statistics and Computer Applications. So it was night session today morning. So R.A. Satyanarayana Garu explained everything. That is a tree decision. There is a decision making kind of scenario. So giving one of the beautiful examples. So how to segregate everything. Okay. So my topic I'm going to deliberate and going to explain. So how to data analysis using R programming. With a small examples and continued with some descriptive statistics and a test of significance. You people aware of the test of significance, how, so where we use the significance kind of scenarios, significance of test. And lastly, I would like to present one best example for cluster analysis. It is a complete multivariate techniques. Okay, so my voice is audible, all of you? My voice is clear? Okay,
Yes,
my
sir.
voice is
Yes, sir.
okay.
Yes,
So
clear, sir. Clear, sir.
okay. So if you have any problem, so let me know. So my phone is there here, so you can contact me. Okay. So today so today my topic and my delivery is the process of data analysis. So why people the hardest, why people knowing, why people know about R. So what is the specialty of R? And followed with the descriptive statistics, the test of significance, ANOVA tables, that is analysis of variance tables, regression and cluster analysis. So today's session, so first I would like to give a small one diagrammatic representation. So here one picture is there. So first one explain actual data and big data, and followed by data analytics and statistical data analysis and decision. So you can see in this particular image and particular diagram, the actual data, big data, it is not proper way. It is a very difficult to understand the data set or otherwise information. And also the objective. So object of the study or case study, whatever it may be. Otherwise you can say simply the aim of the study. It is a completely some kind of uncertainty is there. It is difficult to prepare. It is very difficult to identify to go for data analytics. So this is an actual scenario, actual data framing and big data, sometimes called is a big data. Big data is a different 3 V's is there. There is a versatility is there, velocity of data, the different things is there. Now, okay, so I'm having some data, I'm having some information. So how we go for a data analytics or a statistical data analysis. So if I have actual data, if I have some big data kind of information, so you go and apply. So with using with the statistical data analysis and data analytics, and ultimately, so what is my output? What is my intention is to go for taking some decision. It is a making good decisions. Okay, so that's why here the three pictures, that is a three diagram is showing first one actual data analysis and decision making. Okay, so next to the process of data analysis, it is a very important to apply any statistical tool and a statistical application. So in view of a business scenario. So I used to work some IT companies, there is a Genpact or App Labs and GVK EMR as a data analysis. So who are reporting my manager or head of the institution. So they given only business problem. Okay, so the business problem is there. This is a business problem, and so they expecting business solution. So this was only two criteria. So they don't know. So what is the statistical analysis? What is the data analysis? Everything. And so they given only business problem. So they're expecting business solution. So what is our role and what is the data analytics role? So if I having business problem, if I having business, the aim and business objective, let us take business objective to convert simply the statistical problem. Okay, so these are the statistical problem. Okay, so business problem is there. Just we need to statistical problem and do some statistical data analysis, whatever maybe it is a modeling or it is a experiment or it is a case study, it is a survey study, whatever maybe it is called a data analysis. With using some statistical packages like SPSS, SAS is there nowadays, Python. Okay, so Minitab is there, Guilt is there. So many statistical packages are available in this market. Now simply we do some statistical analysis and we did something that is a statistical solutions. Statistical solutions, you can apply some ARIMA models, you can apply time series models, so whatever may be, and finally the statistical solutions become a business solution. Again here we convert to statistical solution, convert to business solution. So what I am having is statistical solution. For example, I figure out some correlation value and I calculated some R square value, that is a coefficient of determination. I calculated chi-square value, so I calculated the multivariate techniques, cluster analysis, factor analysis, whatever may be. Then ultimately I have some value, some output data, simply I convert to business solution. So finally, so we submit, so boss, this is your business problem, so this is your business solution. In meanwhile, so I do, so these are the processes: statistical problem, data analysis, and statistical solution. So this is the complete the picture of the process of data analysis. Otherwise, we can simply say that process of data analytics. Data analytics. Okay, so this is a simple. So now why are so every people talking about are in a medical or it is engineering or statistics or computer science, and also now is a the trending word is artificial intelligence and machine learning. So last so 5 years back, 10 years back, what I had about so data analysis, there is a big data, big data. Okay, so big data is a very trending the scenario. So everybody are talking about big data, big data, how to make big data, what is a big data, actually where you use the big data. So some kind of in my agriculture, somebody asking to, so big data, what is a big data? So can I relate it to agriculture or not? So many questions are arrived. So now, so people are using so R. So why all? So why people are switching to R? Earlier I used to SPSS. Earlier I used to SAS. Okay, so nowadays I switch to R language. Okay, so why? So this is some reasons are there. There is a free installation and a vast community is there. If you're having any doubts, in any cases, if you have any clarification, the community is there. You can ask and clarify your doubts, clarify your solutions, everything. And the hottest trend it was and integrate with other languages. It is very, very important to integrate with other languages also. So for example, so I have earlier some SPSS data is there, say SPSS output is there. So can I convert a SPSS data to R? So definitely it is integrated with other languages. So platform is independent, latest cutting edge technology and data analytics in a particularly so are in the predictive analytics. It is a high end graphics also. It is a graphics and so I'm talking about it is a very beautiful and very clear. So given so high end graphics in R. So that's why so more people are switching to R. Okay, now facts and related to R language. So here, so I'm giving some of the basic. So why? What are the facts are given? Google uses R to calculate return of investment. That is a ROI of advertisement campaign. So Google, so one of the most popular in the world. So Ford company uses R to improve the design of its vehicle. So see, it is a very interesting. So what is the R improve the design of its vehicles also? It is engineering sector. Twitter uses R to monitor user experiences. They want to need data and collect how many people are using Twitter. So what the main scenario? So what they sharing the complete images or messages, everything. So they can adapt R also. FDA, so there is a Food and Drug Administration uses R to simulate test on a new food. So if I have any introducing new drug, so in a corona vaccine kind of thing, so definitely they can use R and they collected some trials, clinical, one trial, clinical, two trial kind of thing. Okay. The US National Weather Services use R to predict the severe flooding. Okay, so this is one of the interesting area, are using in weather conditions to forecast the weather parameters. The human rights data analytics group uses R to quantify the impact of R. R is being used to the New York Times to create infographics. So these are the small the facts and figures and facts related to our language. Okay, so see it here. So in this slide, what I mentioned, companies using R. So it is a Facebook already adopted using R. That is also Bing and Amazon also is there. Google also is there. American Express is there. IBM, Deloitte, Infosys. So these are the very small the company the companies are using R. This is a big shot companies. Okay, so now when I'm going to explain R, so already Satyanarayana gives some of the R introduction, how we install R, everything. Now here, so my content and my session is so how to create, how to calculate the data set. Now, first one is a descriptive statistics. So you people heard about so why we are applying the descriptive statistics. Descriptive statistics to know characteristics of the data. Simply, we call as the characteristics of the data. Are summarizing, describing, and presenting a series of values, or a series of data set. Okay, so when beginning, so who are beginners, so who are install R and who are beginners, what I'm suggesting. So please go and take simple examples and copy paste so in our R studio, and know about what happened the results. Okay, so here I'm creating yield is there. So this is for yield is one parameter name, and you can take the file name also yield, and C is nothing but is a concat to. So these are my values. Okay, yield values, for example, 28 kgs, 45 kgs, 56 kgs, and so on, 47 kgs. So when we create some data set, so this is a yield. This is some symbol is there, less than, hyphen, and C within brackets. You can create some data set. Okay, so now I'm opened so here so now this is for our studio. So everybody visible this one, the same page
Yes, sir, it is visible.
is visible. So this is for our studio. So what I did earlier, just I copied and paste the yield value. So this is for I paste something here. Okay, yield, that is my values are 25, 45, 56, like that. Now, so when we starting, so this one I want to need some descriptive statistics. Descriptive statistics, so both of a measure of central tendency, measure of dispersion. To know about the characteristics of the data, simply I given the mean values, that is already mean is there, mean dot date is there, mean dot default is there. Now I want to need mean value, so you can type yield, so you will get the mean value. And same thing, I want to need variance, that is VAR within brackets, you can apply. So that is yield is there, yield data, this is a variance value. Okay, same thing. So if you want to some minimum value, MIN, so that is a minimum value starting with brackets, and you can give that is a yield value. So that is a minimum value. So these are the some of the function or functions are available. If you want, you go and so give. So finally, so what is the best function? So I'm given summary. Okay, so summary data. Okay, so you can give your name, the yield. So see it is summary, the yield value minimum is 15, and the first quartile 26, the second quartile 45, it is nothing but median value, and the third quartile 47.7,
ఎవరికి రావట్లేదా? హలో సార్. Not audible, sir. Sir, it's not audible, sir. Sir,
Hello?
Sir,
Okay,
it is
okay.
audible, sir.
Okay. So we'll continue. Okay. So now this is for if I have data that is a yield data. Okay, so you can calculate the summary statistics, everything minimum that is a first quartile, second quartile, third quartile. Okay, so in another way, so if you want to go for some so testing of a hypothesis, okay, so what we'll do here, so one sample t test, it is commonly used as significant that the parameter, so that they value the mean value, it is that the mean value of a sample from the normal distribution or not. So to just to verify, so your value. Okay, now here, so what I did here, so I creating one variable that is age. Okay, so age is one parameter, and my age collected some data 45, 25, 58, 26. So these are the ages are there. Now I'm going to test, for example, t test. Okay, so what is simply you can type t dot test yes comma mu. So mu equals to, so that is a population parameter, that is a mu value. So my mu equals to 50. Okay, so in this R function, in R studio, so I'm creating one variable name that is age. So these are the metadata, and so we'll give the mu equals to 50. So that is a population parameter. So just enter. So this is for your output. So in this output, so alternative hypothesis is true mean is not equals to 50, and your probability value 0.4232. This is for your t statistic value, that is minus 0.8389. So always we taking modulus of t, so this is nothing but 0.8389. So in a practical purpose, you can take degrees of freedom at 9. Why? Because of my values are 10 minus 1 degrees of freedom 9, and you can compare the table value of t value, and it is a significant or not. Now itself here the probability value 0.42, it is a greater than 0.05. So that's why we accept the null hypothesis. So my hypothesis is very clear here. So there is no significant difference between the sample mean and population mean, or otherwise, so your population mean value is 50. Okay, and also it gives 95% confidence interval, that is a 34 and 57. 34, it is a minimum value of 95%, and 51, 57, that is a maximum of the confidence interval. So it means to say the 34 and 57. So always your mean value lies between 34 to 57. And also the sample estimate value of mean value of x equals to 45.7. Okay, so these are the output. This is called one sample t test. It is a very simple the statistical technique to apply the test of significance. Okay, so and also, so when we go for a two sample test, so actually, so where we use the two sample test, the difference between two sample means, otherwise the difference between two standard deviations, the difference between two variations from the so normal distribution. So always we assuming, so our data follows normal distribution. Okay, now so what I did here, so we'll take the two data set, that is a two data creations. So here I created there is a sample 1 and a sample 2. So all of you so observed sample 1, that is I'm giving some values, that is 1 2 3 4 5 6 values are there. In sample 2 6 49 values are there. Okay, so just what I did here, so I want to know the difference between two sample means from the normal distribution. The test is given simply t dot test. So begin with brackets, and you can give the sample 1. So this is for already denoted sample 1 comma and sample 2. So this is for sample 2 is there, sample t. So bracket closed. Okay, so just you can enter the value. Same thing here also, the degrees of freedom is given, and so the t values is there, that is a probability value also is there. Okay, so my alternative hypothesis is there, 95% confidence interval is there, everything is there. So finally, so probability value 0.01, it is this is a less than, so that is a 0.05. Okay, so simply, so we reject the null hypothesis. So and earlier days, so we'll took only t value and compared the table value of t. So we have some tables are there available, but here so always we are noted about that is a probability value 0.01. So less than 0.05, it is nothing but 5% level. It is less than 0.01, it is a 1% level. So now it is a 5% level, significant. Okay, so the alternative hypothesis is very clear, two differences mean is not equal to. So the actual null hypothesis, the equal to zero, alternative hypothesis not equal to 0. So this is for two sample the mean values. Okay, so now, so when we are going to paid t-test, so paid test also is a simple way. So what I did here, I am creating some data set, for example. So I'm creating this one before and after. Actually, the paid t-test is a significant difference between two variables. So before and after, and earlier, now it is a given some two scenarios. Okay, before and after. Okay, so here the condition is the same person or the same candidate, and the pays are equal in this data set. For example, you can imagine, you can take one example. I have students are there, 10 students are there. I conducted one test, there is a before test. So they're getting marks, there is a 45, 26, 59, like that. Same students I have sent to some the training program. Again, I conducted one test, that is after scores or after marks. So some same getting of 59, 18, 64, like that. So it is nothing but the first student got 45 marks before exam, before test score. After test score 59. So it means the training program is benefited, the particular person, the particular guy. Same thing, the second student 26 and 18, so they lost. Okay, so third student 59 and 64, 65, 65. So the fourth students, no difference, nothing is there. That is a 65, 65 is no difference. It is nothing is there. So before March 65, after March 65. Now I have whole set of data. So what I'm going to clarify. So is there significant difference before and after? So for following the 10 students. What is my aim? So my aim is very clear. So my training program is continued or not, or otherwise my coaching to students, it is a continuing or not. Okay, so these are the data set values. Now here the paid t-test, the simply what I did here, so t-test is here, simply so t-test. Okay, okay, so I typed a t-test within brackets. So what I'm giving this one before one data set name, and this is for after data set name, and you can give some paid equals to that is true. So this is for true value, and simply you can enter. Okay, so error unexpected symbol in a t-test before and after paid t-test. Okay, so just I'm classifying once again. Okay, so now it is a p-test is given, data before and after, t value 0.4251, so their probability value 0.68, everything is same. So you people observed, so before one sample test and two sample test, and this is for paid t-test. Okay, so the following output is will be same. The t-test is given, degrees of freedom is there, probability value is there, alternative hypothesis, everything is there, and the thing is there. So earlier it was a two sample, it is a one sample, like that. So here also probability value 0.68, it is greater than 0.05. So simply, so accept the null hypothesis. Accept the null hypothesis is nothing but no difference, nothing is there. So your training is not affected. So your coaching not affected. or otherwise your your training session is not benefited for students. So this is for your conclusion. So this is a very useful method for testing the significant test of significance in a particularly so paid t test. And also so some of the f test is available. So f test to compare two variances. So what we'll do here, so I created some data. See this one. So this is for I created variable 1 and variable 2. Variable I'm having some values, variable 2 I'm having some values. Okay, and the test name is where dot test where 1 comma where 2. So this where 1 it is nothing but the first variable name, and where 2 it is a second variable name. So that's why where comma where 2, this is a where t test. So earlier t dot test, so earlier so I'm using t dot test. Okay, so simply here we can add these two, and this is my test f test to compare two variances. So here, so there is no significant difference between two variables, variable and variable 2 with respect to so their variances. Okay, so my probability value 0.90, always so you compare 0.05 or 0.01. So is there less than 0.05 or less than 0.01, simply you reject your null hypothesis, otherwise you accept null hypothesis. It is nothing but do not reject null hypothesis. So these are the sample estimates also is there. Okay, so these are them given a small test of significance values. So sometimes so non-parametric test is available. For example, in non-parametric test, median test is there, mean test is there, Wilcoxon and rank test is there. Some of the non-parametric things. So there is a completely qualitative data information is there. So that kind of situation you can apply. There is a Wilcoxon U test. Okay. So what I did here, so I'm creating one data set. This is for I'm creating one data set. Again, I used to earlier that is a weight data, that is a 20 kgs, 29 kgs, 24 kgs, like that. Now the test is a Wilcoxon. I'm talking about Wilcoxon U test. So you can type Wilcox. So once I type only WIL, it was given Wilcox dot test. You can enter Wilcox test. Again, they're asking some brackets information. So you can write simply weight. So why we wait here? So and so my variable name is weight. Okay, so comma and mu equals to so that is a mu equals to, that is given 18 or 18.5. So it is I'm given only this one, and you can enter. So I have some mistake here, so you can copy and paste here. So in this scenario, so Wilcox weight. Okay, so Wilcox test weight mu equals to 18.5 and a probability value. So if I have probability value 0.005, it is nothing but less than 0.05. So it is a significant at 5, so 1% level. So why? Because of less than 0.01. So this is kind of non-parametric test. Same thing. So another the test is called moods test is there to compare the medians of two or more groups. Okay, so these are the completely I'm talking about a test of significance values. So when it comes to the popular the statistical test in non-parametric, that is chi-square test. So so every time to apply a chi-square test to know about the relationship or association between two variables, more than two variables, kind of scenarios, in particularly socio-economic demographic variables. Okay, so sometimes I used to some kind of gender, sometimes caste, sometimes religion, sometimes I'm asking some opinion questions. Okay, so these are the some of the data to obtain and to construct some cross tabulations. So then we'll use the chi-square test. It is a most popular the tool. So okay, so earlier, so I'm creating one data. So I'm creating this kind of data. Okay, see this one. gender. So this is for gender. C, this is a creating 1 to 1 to 2. It is nothing but male equals to 1 and female equals to 2. That is a 1 comma 2 comma 1 comma 2 comma like that. This is a male and a female. Okay. So then and another I create one data set. So they're called opinion. Okay. So these are the opinion data. It is also here one is nothing but like and dislike is it 2. So just I'm coded here. So before I'm collecting data, there is a 1 equals to male and 2 equals to female and their opinions. I'm asking questions. So do you favor or so do you like coffee or tea like that? So that is a like and dislike data. So my intention, my object is to know the association between gender versus their opinion. So data. Okay. So the that is a chi-square test. I'm talking about chi-square test. Okay. So here also I'm giving. So chi-square test is there. So CHISQ dot test is there. So you can click on this one and you can mention so your data set. So first one data gender comma and opinion. So opinion is there. So this is opinion is there. Okay. So just click on your enter data and to know about this is for Pearson chi-square test with 8 continuity corrections and a chi-square value that is given a 0 0.0 something. So that is given 1.1524 e minus 31. It is nothing but 0.30 zeros, then the value 1.15. The degrees of freedom 1. So why? Because of so gender category, that is a male and female, that is a 2 rows. Opinion like and dislike is nothing but 2 columns. 2 minus 1 multiplied by 2 minus 1, that is a 1 into 1. Degrees of freedom is 1. That is a probability value exactly. So 1 value. Okay. So you can compare again 0.05. Always in test of significance, so then we compare probability value with 0.05 or 0.05. Okay. So this is kind of one chi-square test. Okay. So when we are talking about normality test, so normality, it is a one kind of test to apply the data follows normality or not. Somebody earlier today morning, somebody asking about in Arima and kind of some normality. So definitely you people, so once you have data, so you can go and check it, your data follows normality or not. If once your data follows normality, no problem, nothing is there. You can go and predict, you can go and build some statistical models like regression, multiple linear regression or logistic regression, so whatever may be. Otherwise, if a data does not follows your normality, so definitely you go under some transformation techniques. So already some transformation techniques are available. That is some of the transformation techniques are log x square, otherwise sine arc transformations. So many transformations are available only based on depend upon your data. Now here normality test, one of the test name is called Shapiro-Wilks test. It is the most powerful popular test to test the normality for univariate data. I'm not talking about multivariate data, univariate data. Okay, so let's see. What happened here? This is my data set. So here every time I create a different data set names. So sometimes variable no one, sometimes I created genders, or sometimes I created opinion like that. Now here in this Shapiro-Wilks test, I used to my file name is U1. Otherwise, the parameter name is U1. Now here, so what is the test name? The R function. So just I click on SHA. That's it. Already is there. Shapiro test is there, and Shapiro ratio is there. Shapiro ratio annualized is there. Everything is there. Now I want to need Shapiro dot test. So you can enter Shapiro dot test. Now, so what else here? You can mention just only U1. So why U1? So already I created U1 name. So that is test name. Now see it here. This is for result Shapiro-Wilks normal test data U1. That is also probability value 0.87. Okay, so how we infer? So inference is very, very important. So conclusion part is very, very important. So now here my probability value greater than 0.05. So that's implying that the distribution of the data are not significantly different from normal distribution. In other words, we can assume the normality. Okay, so this is one kind of normal test. Okay, so now, so part of the correlation. So actually, so where we use correlation, so you can use correlation both independent variables, you can use correlation both dependent variables, you can use correlation both independent and dependent variable. So finally, to know about the linear relationship, that strength of relationship between two variables. Okay, so it is two variables. It is a nothing but both are quantitative variables, not qualitative variables. If you have qualitative variables, again you go for ranks test. Now it is, I'm talking about correlation. It is a continuous variables. Now here simply, so what I did here, so I creating two data sets. So this is one for correlate yield data, and the second one is a rainfall. No, so is there a relationship or not? So yes, definitely is there relationship between yield and rainfall. So what is the my aim? So simply I go for a correlate and to know about is the relationship between yield and rainfall. It is nothing but rainfall or increases. When increases, so their corresponding the yield value are increases or decreases. I want to know some relationship. So using the correlation value. Now it comes to what is the R, so that is a correlation value. So simply what I did here, this one COR, this is a core dot test. You can use core dot test, already is available core test, and within brackets again simply you can type yield comma rainfall. So why yield comma, already I mentioned a variables, I created some variables yield comma rainfall. So okay, so this one already, so rainfall data is there, rainfall. Okay, so already is the rainfall is there. Now you can enter, press the enter. See it here, see the results. So Pearson, the product movement correlation. So that is your yield value is there, T value, everything is available. So what earlier T dot test, that is a paid test, everything. So what is our p value? P value equals to 0.94. Okay, so it is again, it is a non-significant. Why? Because of probability value greater than 0.05. It is a non-significant. Non-significant is nothing but no relationship, nothing is there between two variables. So what we have variables? Variables are yield and rainfall. There is no relationship. So if relationship is there, definitely your R value is there. So everything is there. Okay, so this is a product movement correlation, and also test is there. If you want to correlation, you can just type this one correlation value, and you can give so your data. So that is yield data. Okay, so and this one next rainfall data. Okay, so this one correlation is there, and this one yield data comma rainfall data. Okay, so your correlation is a negatively correlation minus 0.031. Okay, so this is for a correlation. It is a very good tool for applying the quantitative data. So when it comes to the linear regression, that is I'm talking about simple linear regression. Okay, so what is a linear regression? So it is the regression, it comes to one dependent variable, it has one independent variable. Okay, so actually the regression in a dictionary word is a stepping back on average value. Okay, so to give something, to know something. So for example, I'm having some dependent variable, I'm having some independent variable. You can substitute some independent variable, so you can estimate, you can predict, you can forecast what is your dependent variable. And also, is there some cause and relationship, cause and relationship between two variables? Okay, so in this scenario, so what I did here, so I create two data set. The data set name is, the one is DE. DE is nothing but dependent variable, and the another independent variable. So that is IND. IND is a independent variable. So what are my assumption is dependent variable and independent variable is some relationship is there. Okay. So now when comes to independent and dependent variable, and my simple linear regression, what I did here, model, I'm creating one variable name. Okay, so less than small hyphen, that is a LM is there, linear model, brackets open, DE, so that is one symbol is a tilde, it is called tilde. So you can operate to shift plus that is a tilde, some button is there, it is escape button top, escape before escape button is there, you can type DE tilde IND, so that is called IND, so that's it, so you can enter the data. Okay, so now here in this one I want to now model. Okay, so this is your linear model, coefficients is there, everything is there. Now when it comes to I'm a DE dependent variable, independent variable, now I want to need so some of the values, that is a head, so within brackets, okay, you can enter, so that head is there, once again within brackets head and DE is there. Okay, so it is nothing but 14 26 59 like that. So I have 10 values, 10 or 12 values are there in a dependent variable. May I know what is the values? So same thing here, the head, one of the function is there, you can enter this one, and independent IND you can enter. Okay, so these are the last part of data, so it is nothing but last of data. Head D, it is a first part of data, and last part of data, if you want to tail within brackets, that is D, so there is a last part of data. So if you want to see, so in my example is a 12 data points, it is okay. So but I have the huge data set is there, some thousands of data is there, some millions of the data is there. Okay, it's just you can type to, so if you want to the nature of data, you can type to that is a head and a tail. So head is a nothing but it represents the first part of data, tail is a nothing but last part of data. Other also, so today morning, Satyanarayana is told, and they given n call, that is a n columns. Okay, so within brackets, so n columns, that is a DE, so it is a null. So number of columns. If you want to number of rows, that is a n row. That is a n row already is given. Okay, so. So that is a n row, it is a error, or otherwise n row you can enter DE. So that is a dependent variable. So that is number of rows and number of columns also is there. So okay, so this is for simple linear regression. Okay, when it comes to in analysis part, so when I'm having some dependent variable, some independent variable, so I want to know that is a model coefficients. Okay, so earlier, so I created some data, so that is a dependent variable, independent variable. Now I want to see the coefficients of model. So just type coefficients dot model, you can enter. So these are the intercept value, and D value is there. Okay, so now, so confidence intervals. Okay, so I want to need confidence intervals. Okay, so confint. So the one function is there, CONFINT. Confint is there. You can type confint, and you can type model. So already I used to model, comma. Okay, so level equals to 0.95. Okay, so this is for confidence limits, you can enter. So these are the confidence limits, intercept value and independent value. Now, so the fitted model. Okay, so already I created, see all of you look here, this is a dependent variable, this is my values, independent variables, my values. Just these two parameters, these two variables, dependent, independent, I used to create the another way, that is a model less than or equals to LM that is a DE tilde IND. So this is for my final the model name. That is a model 1, model 2. You can specify anything. Now comes to here coefficients model, confit model comma level equals to 0.05. When comes to fitted, so these are the fitted. You can use model. The model is name. Okay, fitted model. So you can enter. This is for predicted model prediction. So what I did is this one 37. So what is a dependent? So dependent value, this is a dependent 14. So we estimated this is a 37. Second value 26. So here the second value 55, like that. These are the fitted values. When comes to residual analysis, so that is given some residuals is there. So you can type residuals, you can give model, that is okay. So these are the residuals, some positive values or some negative values. Okay, so same thing, if you want to ANOVA, you can type I think ANOVA model. This is for ANOVA thing. Okay, so if you want to ANOVA, okay, so you can so type this one model, this one. This is ANOVA model, residuals and degrees of freedom, everything ANOVA model. Sometimes if you want to diagnostics your model, so definitely you can type influence, this one influence and model. Okay, so this is for influence, so I think. Okay, so influence and model is there. Influence model. Okay, regression diagnostics, that is influence model. Okay, so here some given model name is given. So diagnostics, same thing here. You can layout. So diagnostic text also is there. Let us layout. Okay, so now plot the model. You can type something here. This is your model. See it here. So this is for left side, right side graph, and if you want to zoom, you can zoom here. So I'm audible. So this is a picture. This is for given some normal QQ plot. There is a quantity plot and residuals for fitted plot. This is for scale and location. Residual for leverage. So this is for advanced test or advanced diagnostic test. To your model is correct or not. Somebody today morning asked, so how to fitted our model, how to over fitted model. For seeing this one normal QU plot, this is for standardized residuals. My all the points very close to that line. It is nothing but it is a good fitted model. Otherwise, so far away. So this line, my all the data lines, my all the data things, it should be aware of this line. It is nothing but your data does not follows normality, not fitted diagrammatic representations. So simply here, what I did here, layout matrix, that is a column 1, 2, 3, 4. So that is a 2 rows, 2 columns. Last 2, 2, it is a stands for 2 rows, 2 columns. 1, 2, 3. So that is a 4 images. It is nothing but 1, 2, 3, and 4. 4 images. This is a layout of matrix. So just to simply plot a model. Okay. So this is for given the model also. Okay, so this is for small R functions are available. Okay, now when comes to when comes to R Studio, okay, so then we'll go for some ANOVA technique. Okay, so analysis of variance. Okay. So what I'm suggesting, so before going to analysis of variance, okay, analysis of variance, so you should load the packages. So definitely you need packages. Some of the packages here I mentioned, there is aggredat, ggplot, plot races and movements, car kind of thing. Some of the suggested things. So what is the ANOVA? Analysis of variance. It is a commonly used the study for differences between two or more groups. If I having two groups, do not apply ANOVA. If I have two groups, just you can apply only t-test. T-test, significance of t-test, significance of two groups with respect to their means, with respect to standard deviations, with respect to their variances. But here my problem is I'm having data more than two groups. 3, 4, 5 groups are there. Okay, so then you can apply analysis of variance. So simply you can call as this particular ANOVA test extension of t-test. Extension of t-test. So t-test having two variables, two groups, but here more than two groups, we can apply ANOVA table. So it is a situation so where factor variable has more than one group. So it is based on a completely linear model. So some of the assumptions are there. So the important assumptions, so data independence, normality, equality of variances between groups. Okay, so assumptions, all assumptions are satisfied. You can apply the ANOVA table or analysis of variance things. Now, when we are talking about analysis of variance, okay, variance. So here in this picture, I created some data. The data is the treatments 3 and block 3. These are the yield values. See it here. So right side, so these are the yield value. These are I'm having 3 treatments and 3 blocks. Okay, so they're getting some yield value. So yield value is nothing but 2.56 kgs, so 3.56 kgs like that. Okay, so I'm having some data and I'm going to create my database. This is my local database that is called my data less than or equals to read CSV file, choose file's name, create data set and import the data set. Okay, so here what I did already in my Excel sheet in my desktop, already I created Excel sheet. Okay. Okay, so now simply what happened? Okay, so just I'm going to take with the help of R Studio. Okay, so these are the R Studio. Okay. Now here what I did and my data. This is simply my data less than hyphen read CSV file, choose files data and entering. So again, so they're asking some data set. This one desktop is there, and here I created some data already. My data open. Okay, so this is my data. So see this one, my data already is there now. This is my data. This is for simply, so I created an import some data. Same thing here, yield treatment and block wise data is there. Okay. So now here, what I did here, so again, the function is called str. Okay, str brackets, and simply you can type my data. You can observe, so what it gives here. What gives here? So data frame. Okay, 12 observations, 3 variables. 12 observations, 3 variables. It is nothing but my rows, 2 observations and 3 variables. Yield, treatment, black, 3 variables. And the same thing here, yield numbers 2.56 to 3.56. They mentioned some of the values. And treatment, character, and block is a character. Treatment 1, treatment 2, treatment 1. So it is a very useful function to know about what is the characteristics of the so data view. So data view. Okay. So now, so we can apply some check the normality for histogram. Okay. So what I did here, so one of the function is there. Okay. Hist my data $sign yield. Okay. So these are the my data. You can see it here. So this is for your normality histogram of yield value. Histogram of my yield value. So my data set is there 2 to 3. These are the values. yield values. That is a minimum value, I think 2, the maximum value is 9. This is a histogram of the data. So if you want to another name, there is a yield is okay. Now treatment black, but treatment is a characteristic data, and black also it is a characteristic data. So does not comes to here. Okay, so why? So the histogram is a very useful for checking the normality. Okay, so and also one of the another the function is there, that is a QQ norm. Okay, so see this one. This is for QQ plot yield value. Okay, this is for also one of the technique to check the normality. So another way, if you want to skewness, data, you can type that is a skewness my data yield value. Why I'm targeting yield value? Yield is my dependent variable, my target variable. That is called sometimes called that is a response variable. Okay, so now here, so my skewness value, some minus value, that is a less than 0.5. So consider the deviation from normality, not big enough to transform the data. It is nothing but no need of transform the your data. So if data does not follows normality, then definitely you can go and transform your actual values. Actual values is nothing but your yield values. You can transform to percentage or to x squares or square root of x plus 1. The various transformation techniques are available. Okay, so this is for the skewness data. When it comes to in a one-way ANOVA, so when one comes to it a one-way ANOVA, so what I'm giving is create one table, that is a fit one less than or equal to AOV. So that is an analysis of variance. Yield is my dependent variable. Treatment is my independent variable. So here I'm considered as only one. You can observe or not. So I'm considering only one independent variable, one dependent variable. Data equals to my data. Okay, so already I created my data. So that is my name is file name is my data. Fit one less than or equals to AOV yield tilde like that. Okay, so now just you can enter this one, that is a fit one. Okay, so fit one data. So this is for your coefficients like that, fit one. Okay, now here if you want to on our table summary. Okay, so summary matrix is there, or otherwise summary fit one. Okay, so can use the summary data, summary fit one. Summary data fit one. So this is for degrees of freedom, everything is there. So it's a summary fit one. The treatment residuals, so everything is there, and their corresponding the probability value is there. There is a treatment 0.349. Okay, so the residual values is also is there. Okay, so when comes to two-way, so you need to two independent variables, one dependent variable. So that is given here. Another Excel, another variable name I created here. This one fit 2. So earlier it was fit 1, now it is a fit 2. I created new variable name less than or equals to analysis of variance yield tilde treatment plus block. So why treatment one variable is there here? This is a treatment and block. So earlier one way analysis of variance. So we consider as yield and treat. Now this is two-way classification, two-way analysis of variance. So that's why I consider yield tilde treatment plus block. Okay, so my data, you close the brackets and you can enter. So this is for the coefficient values and summary. Okay, so summary brackets, so you can simply fit to data. This is for analysis of variance. Now see it. So how we conclude here? So I concluded treatment wise. This is your probability value greater than 0.05. It is not significant. Okay, treatment wise. Block wise also your probability value 0.124, which is also greater than 0.05. It is non-significant. It is nothing but among the treatments. We have 3 treatments. So that's why 3 minus 1, 2. So blocks, so it is 4 blocks are there. There is a degrees of freedom. It is also not significant at blocks level also. Okay, now when it comes to some of the plotting is nothing but graphical representations. So here layout is there. Now when it comes to I'm giving plot 1, so that is plot within brackets fit 1. So already one way is there. This is for fit number 1. Next comes to here, so that is fit 2. I'm giving fit 2 value. Okay, so fit 2 is not working, no factor predictors. Okay, so when it comes to here 2K multiple comparison test, so sometimes we used to 2K multiple comparison race tests. So sometimes Duncan multiple race test like that. Okay, so same thing here also 2K test. So 2K fit 1 the confidence level is 0.05. So these are the comparison test. Okay, multiple comparison test. For example, here treatment 2, treatment 1. So that is a difference is there. That is a lower value. Treatment 3 and treatment 2, treatment 3. These are the combinations. So I have 3 combinations: 1, 2, 1, 3, 2, 3. So same thing. This is one upper value. This is a probability value. It is a significant or not. So it is a mentioned. So the R function is simply 2K TUKEY fit comma 1. So if you can take fit number fit 2, that is a two-way analysis of variance. Same thing, your confidence level 0.95. So if you want to confidence level 99%, so you can take 0.99 also, no problem. So it is kind of some the ANOVA technique. Okay, so when it comes to in a cluster analysis, the last part of today, so I'm taking some within I completed within 10 or 15 minutes. Okay, so so this is a PowerPoint presentation is visible.
Yes,
All of
sir.
it? Okay,
Yes,
okay.
sir.
So first we know what is a cluster. Okay, so already cluster analysis is there. It is a kind of multiple analysis technique. Sometimes we call it as a classification techniques. Sometimes we call as this is a unsupervised modeling, unsupervised techniques. Actually, cluster is a small group of people or things. So we have some kind of data. We have some kind of data set. So we are segregating. We are classifying different groups on their similarities, or otherwise data segmentation techniques. So sometimes called as a segmentation techniques, data segmentation techniques. It is simply to partitions into groups. Groups is nothing but here the technical word is cluster, several groups. So how we define, how you classified groups, different groups, several groups. Okay, it is based on their similarities. Okay, so sometimes to classify objects or cases also. Sometimes we want to need classify cases. Sometimes we need to classify objects with relating their groups also. Okay, it is a most powerful techniques nowadays for unsupervised modeling, unsupervised techniques, unsupervised modeling. Okay, cluster is a technique of data segmentation that partition of the data into several groups based on the similarity. Okay, so why is the unsupervised learning algorithm? Unsupervised model is there. unsupervised model. So here they don't have any aim, they don't have any independent variables and dependent variables. So that's why we call as unsupervised modeling, unsupervised learning algorithm. Okay, it is a complete based on their similarity. Okay, their similarity. Now when it comes to some of the applications, so to be understand very easily, so how we in marketing, the cluster analysis versus marketing, cluster analysis versus retail segment, retail sector or their particular domain, medical sciences and sociology. Now in particularly in marketing, to explore and select customers that are potential buyers of the product, this is differentiation to most likable customers from the ones who possesses to least tendency to purchase the product. So in IT sector, some of the projects they know about. So why how to retain the customers? How to retain the customers again? So their units. So some of the DMarts are there, Big Bazaar units are there, okay, Reliance markets are there. The customers are there, millions of customers, and they collected some phone numbers. They offering some percentages. So that is a discount purchase. So once you entered, once you first time you entered visiting and market, so definitely they collected some your phone numbers. Okay, so they keep on maintain phone numbers and they are analyzing. So what is how much they purchase, how many times are visited, everything. Okay, so they analyze and they looking and they found some of the people not coming again and again. So they don't know. So what is the reason? So they are not interested to visit again unit in my sector, in my organization. So whatever may be. Okay, so in cluster analysis, it is one of the one kind of best technique to know and solve these kind of things. Okay, so in a retail industries, make use of clustering to group customers based on their that is a preferences, style, choice of the where well store preferences. Okay, medicine, medical sciences, medicine and health industries make use the clustering algorithm to facilitate efficient diagnosis and treatment of their patients as well as the discovery of new medicines. It is one of the best example in medical sciences. And particularly sociology, there is some of the people who background in social sciences. Social sciences, okay. Sociology clustering used data mining operations divide people based on their demographics, lifestyle, socio-economic status, etc. So the some of the extension people are there, sociology people, economics people, their background I'm talking about. It's very useful technique, clustering analysis or segmentation analysis. Okay, so here before going to cluster analysis, so definitely you need to install packages. So here giving some kind of TDverse, cluster, facto extra and grid extra, etc. These are the what I'm suggesting, what I'm suggesting. So please you people installing. So these are the R Studio. Everybody the same pitch and same this one. Here some of the packages are available here. Some of the packages are available. Now here install is there. So this is a files, plots, packages help. I'm talking about the bottom right side. So packages, now install here packages. Now you can click on install. Okay, so my TD was this one TD curve. So what I'm TADIY. Okay, so TADIY. So DD was okay. So this is a TD words is already available. You can packages separate multiple with space comma and install dependencies also. Always you click on install dependencies. Why? Because of the packages once loaded, automatically the dependency packages also it is downloaded. Now comes to you can click on button here. So here your R Studio restarting R session. It's take some time. Okay, so install packages DDWares. Okay, so now once you completed, you can type library again. So this installation packages are there. Okay, so once package you were downloaded, again type library. So this one uh, TD words. So already is there. This one TD words is there. You can enter. Okay, so like that. Okay, so it is very important for install your packages in R. Okay. Now comes to so already so default one data is there now available. So that is called so US arrest is there. One data set already it is inbuilt data set. Data US arrest is there. Okay, so now here this is for data. Now coming to here, I want to know again. So what is the data comes this one, or otherwise simply I go for str. Okay, so you can type str and this one US. Okay, and arrest is there. Okay, this is type. Now see here, this is for complete things one. Now 50 observations, 4 variables. 50 observations, 4 variables. So the variable names are called murder, assault, urban pop. It is a rape. So 4 variables. So 50 observations. Okay, this is for data frame. Already is given a default section. So in cluster analysis, I am going to take the K means cluster, K means algorithm. Okay. So now what I did, first one, I create one data frame that is a D underscore frame. So US arrest. Okay. Now this is my data frame. And then I remove all the missing values. If I have missing values, just I remove missing values. That is the same D underscore frame less than or equals to NA dot omit D frame within brackets. Now it is clear removing all the missing values. Now when comes to again scaled, I convert them scale values. Just type D underscore frame less than or equals to scale D underscore frame. So this is also clear. And now head frame. This is for head frame. See this one. This is for some results are there head. So these are the some states are there: Alabama, Alexa, Arizona, Arkansas. This one. So these are the values are murder, assault. Now scaled values. Scale is nothing but normalized scales. So sometimes mean minus a standard deviation values kind of thing. This is a murder, assault. There is a 4 variables. So already we know about 4 variables. So where comes to actually this data already inbuilt data set, that is US arrests are there. Okay. Now when comes to so this kind of data, what I'm using so here K means clusters. That is K means clusters. Now this is for K means clusters. K means 2. Oh, I am prepared some variable name less than or equals to K means D underscore frame centers equals to 2 N start equals to 25. Okay, so just I entered this one. Okay, so now comes to here you can type str. Okay, so str brackets open, that is K means already K means 2. Already I mentioned data K means 2. Okay, so str okay, not working here. Okay, so these are the given they were output, the clusters, everything. List of 9. Okay, so these are the some of the strk means. Once I already K means there is a D frame centers 2 and N start to 25. I mentioned here. Now comes to here. This is very, very important for clustering. So these are the plots are available here. If is not working. Okay, so just you can go and packages. So once install factor etc. install. So just a minute, install some packages. Okay, so it is not working. So some of the installation problem is there. Okay, not a problem. So once I'm putting this one, uh, I have some input. So like that. So these are my output. So all of you look here, this one. It is nothing but so two clusters. That is a k equals to two clusters. This is for dimension 1. This is for dimension 2. I want to need that is a clusters, three clusters. That is a three clusters. The nearby, very nearest k means algorithm. Okay, so 50 observations, 4 variables. This is for dimension 1 and dimension 2. So dimension 1 it is a respect to 62%, dimension 2 is a 27.7%. Same thing if you want to k equals to 4 and k equals to 5, same thing. So this is a 5 clusters. Okay, so if you want to, so how we decide the cluster? So you can take under 2 or 3. Otherwise, what is the maximum cluster? So some of the options are there. So in our studio, so if you go and uh, give the maximum clusters of so our studio. Okay, so this is kind of some cluster analysis. So how we segregate the clusters. Okay, so same thing here. We can take the another way. Okay, so so dendrogram is available. Okay, so you can see here some time of dendrogram here. So this is called for a dendrogram, cluster dendrogram. So in a dendrogram is a represent, it is a one kind of so graphical representations to know the 3 clusters are available. If you want to 2 clusters, so here some color is there. First color is there. There is a rose color and a green and blue color is a one cluster. So there is this is one cluster, completely one cluster. This is a one cluster. Otherwise, if you want to 3 clusters, again this is one cluster, green is one cluster, and blue is a one cluster. So these are the observations are given. So they're completely, so they're based on their similarities. Okay, now here some kind of the pictures are representing here some graphical representations. So here the first one is the iris data. So this is looking good for graphs representation. So there is a second graph is a representation, that is heat graph. Okay, principal component analysis kind of thing. And the third one some graphical bar and outliers, some box and whisker plot is available. And the third one is this is a dendrogram. This is a cyclogram graph also. So this is for some cluster plot. Again here the mentioned 4 cluster plots. Okay, so now here some zigzag curve is that this is a completely time series data, time series part of thing here. Okay, so this is kind of some 3D dimensional pictures are available here. Okay, so here I mentioned. And lastly, I mentioned one of the 2 bloggers, that is 2 website, the links are given. Okay, it is very useful to for understanding the R Studio and so R programs. Okay. Okay, so anything else? So if you have any queries, any questions, please.
Thank you, sir. We will go ahead and take some time for questions. Any questions?
I'm asking the participants if I have any questions. So if beginners, so do not go for multivariate, do not go for the sophisticated, advanced techniques. So what you did, people? So I have some slides. Definitely, I sent to you to who are conducting. So this webinar. Okay, so please just you open studio or studio and I am explain. So how we install and our studio, and we just copy and paste. So what I mentioned here, significant descriptive statistics kind of thing, you just copy and paste and see it what is your output. And then if you have anything, if you want to go and what is a required the installation packages, already some of the packages I mentioned. Otherwise you google and find some of the packages. So once you install packages, again you can type library, you can check it. So that package is name, and do the statistical analysis or statistical tools, whatever. Okay.
Yes. Yes, sir. Jairam.
Okay, Anita.
Sir?
It's completed.
One question. Yes, yes. Wait,
Questions,
sir.
if you have any queries, questions.
Sir, one question in the chat box, sir, whether
Yes.
R can be used for FCM analysis.
Very
FCM analysis can also use R.
support
And test and LSD. Sir, is it hard, sir?
okay. Group chat, where is questions? Hello, madam.
Sir.
Hello. Madam. So
Yes.
yes. Structural equation modeling. I think SEM. Yes. So we can you can use CM in analysis also. So the thing is that if you want to go and analyze, understand the data structures and object of this. Unless until you don't understand, you're unable to understand the kind of data, it is very difficult to apply our modeling in R. So somebody is morning asked the Arima is not a easy thing to apply autoregressive integrated moving averages. You check the component of time series, okay, and normal testing, everything is. So then you can apply auto Arima also available. Okay, so SEM you can.
Sir?
Hello?
Sir,
Hello, sir? Hello, sir? Can you hear me?
Yes, sir.
Yeah,
Proceed.
I have a question. Yeah, I have a question.
Okay, sir.
Can,
Proceed, sir.
yeah. Can you explain the difference between the 2K test and LSD?
Umar sir?
Sir, Umar sir, are you there? So,
Can I
Umar
just
sir?
wait for 5 minutes, sir?
Yeah, no problem, ma'am. No problem.
Yeah. ఆఫ్ చేశాను సార్ ఫోన్ చేస్తామా
Hello.
సార్ ఉమర్ సార్
చెప్పండి.
సార్
Yes.
one more question, sir.
Okay.
Yes. Whether R can be used for SEM analysis?
Yes. Structural equation modeling, so you can use in R, not a problem. So they related some install packages are needed. You can install their relative packages. You can install in R Studio. So you can SEM also, SVM also, support vector machine also. But you people identify so which are suitable, which are flexible for packages in. So around I think so I had about 2000 packages are available in R.
Nagesh sir is there?
Yeah, sir. Sir, good afternoon, sir.
Good afternoon. Yes, tell me.
So, yeah, very informative session, sir. Thank you very much.
Okay.
So, I have a question, sir.
Yes,
So,
go ahead.
may I know the difference between the 2K test and LSD? So, because both the tests are used for the multiple comparison only. Is it so,
Okay.
sir?
No. So in a multiple comparison test, the factorial experiment also involved. Once in design of experiment, so what we'll do actually, we used to only CRD, RBD, LSD, one way, two way, three way analysis. If I have added more factors, you can go for a multiple range test. The multiple range test is the different scenarios is there. Duncan multiple range test, that is a DMR test is there. Okay, 2K is test is there, Shafi's test is there. It is all multiple comparison tests. It is dependent upon their objectives. Okay, so not for common for all us.
Sir, that means we can't apply for LSD and 2K test in both both are in the same direction.
No.
Yeah.
So multiple
Okay.
comparison is a different scenario. Latin squared, as you talking about LSD, that Latin square design, number of rows, columns, and treatments are equal. You can apply LSD. It is not a problem. If you want to know, compare the multiple range test with respect to their mean value.
Okay. Definitely, you have to go for the 2K test only. Yeah, at that time you have to take the 2K test only. Is it so, sir?
2000 packages in R Studio need to be explored. No, Dr. Manjunath asking 2000 packages in R Studio need to be explored. No need of 2000 packages. What I am suggesting, so if you want to suitable for your data set, you can go and load the packages, explore the packages. Otherwise, no need of all 2000 packages. Dr. Manjunath. No need of all 2000 packages. So it is a criteria. It is my criteria is different. My case study is different. My experiment is different. I go and install. Okay. So so your criteria is different. If you want to time series, you go and explore. You go and install all the categories, all the related to time series packages if you want. So anything else? So from my side.
Yes. Any more questions?
Any more questions or anything from my side?
Okay, sir. Thank you, sir.
Okay. Thank you.
for answering those questions. And I take this opportunity and thanks to Dr. S. Nafis Umar sir for his wonderful presentation on descriptive statistics used in different areas to know the characteristics of data set. So testing of hypothesis is testing is an act in statistics. This methodology is very useful in the nature of the data for the analysis. Correlation and regression tools useful to relationship and predicting upcoming values. It is useful and helpful for business decision making scenarios. Nowadays, statistics plays an important role in different industries to found some important inferences. It's a very wonderful presentation, sir. Thank you very much, sir.
Okay, thank you.
Now I request Vani ma'am to propose the vote of thanks. Over to Vani ma'am.
Thank you, sir. On behalf of Department of Statistics, it is my privilege to propose vote of thanks. First of all, I would like to thank our Honorable Vice Chancellor, Professor D. Jananaman, for encouraging and supporting us to organize this webinar. I thank Registrar Professor Mahila for her support. I profusely thank Professor R. Nagaraju sir, Dean School of Sciences. With heart full of gratitude, I thank Professor G. Sandhya ma'am, Head of the Department, for all the moral support to organize this webinar. I extend my thanks to our resource persons, Dr. Sheikh Nafis Umar sir and Sri Arya Satyanarayana sir, to take out time from their busy schedule to grace this event. Thank you for inspiring and encouraging us with your words. And I take this opportunity to extend our heartfelt thanks to all the participants for your active participation. With these warm words and a kind message, we move to the end of today's national webinar. Thank you, one and all.
Satyanarayan sir, we will give contact number of Umar sir. If you have any doubts, please contact Umar sir.
Okay.
Okay, thank you, sir. I request all the participants to fill the feedback form provided in the chat box so as to receive e-certificate immediately. Per day only 100 e-certificates will be generated. Okay, thank you. Now we are wondering of the session. Thank you. Thank you, everyone. Sir.